I'm going over the notes for my own version of section 1.2 that will not match any other teacher's 1.2, I promise. It's completely different. Segment addition postulate and midpoint. And that's what I felt like we needed to cover today, and so that's what I'm going to do. So if B, segment addition postulate, remember I told you yesterday a postulate is something that's just obviously true. It doesn't need a proof to explain it. It's just accepted. So a segment addition postulate is one of those things. If B is between 2 points A and C, then, oops, what am I doing? There we go. Then AB, segment AB, plus segment BC equals segment AC. That's the postulate, which all that's saying is if B is between 2 points, A and C, then one piece plus the other piece equals the whole thing. Another way of saying that is if I had a stick and I broke the stick into 2 pieces, if I put those 2 pieces back together again, it would be the length of the original stick. Makes sense, right? That's why it's a postulate. It doesn't require a mathematical proof. It's just true. So then in a diagram version, if we have AC and point B is between them, it looks like this. And if you add the 2 sections together, they will equal the whole. So AB plus BC equals the whole thing AC. So the yellow plus the green equals the pink, right? And we use this postulate a lot. Later on, the segment addition postulate, I'm just going to be abbreviating that as SAP. Because when we get to proofs, and we have to write it like for our justification for that step, I don't like writing that out the whole time, so I'll just write SAP. So SAP, segment addition postulate. Okay, so we're going to determine the length of a line segment. Write the justification for each step. B is between A and C. All right, so I like to stop right there. He gave me something, sketch it out in geometry. Best way to start any problem is to make a quick sketch. Your artistry does not matter. If you don't have strong artistic abilities, it's okay. We can all sketch a straight line and put some dots on it. And if not, you're probably the only one that's going to see it, maybe me. And I won't judge. All right, so B is between A and C. So here's A, here's C. Those are the end points. B is between. Notice I don't have the dot exactly in the middle because it doesn't say in the middle. In the middle is giving you an exact location, right? It's saying it's the same on both sides. That's not the same thing as saying between. I don't know what the distance is. I have no idea. It might be in the middle, but I don't know. So you can't just, so if you put the dot in the middle whenever it says between, you'll probably end up making the mistake of calling it a midpoint when it's not. So that's why it's over here on the side. All right, there's my sketch. AB is 5. All right, so I'm going to take information. AB is 5. Here's AB. That's 5 right there. And also I can do it in equation form at the same time. AB is 5. BC is 10. Here's BC is 10. From B to C, that's 10. BC, that's 10. Find AC. All right. From A to C. What's the length of AC?
15.
15, exactly. You add the 2 pieces together, you get the whole thing. And that's exactly what we're doing. This is an overly simplified example, right? Because I like to keep things simple. But if you add the 2 pieces together, you get the whole thing. And really all of these little letters should have a little line on top because they are line segments. I just taught you all that yesterday, and now my paper today doesn't have it there. That's Not very good teacher skills. Oh well. Number 2, S is between R and T. There's not a place for a number line, but I can draw one. There. It's magnificent art. S is in the middle of R and T, so that means that R and T are on the outsides. My detective skills. S is in between. It doesn't matter where I put the dot, but I don't really want it exactly in the middle because that's misleading. So I'm just going to put it there. And then it gives me information. RS is 2x. So from R to S, that's 2x. Or I could do it in the equation part over here. RS is 2x. ST is 10. So from S to T, that's 10. And this time it tells me that the whole length, RT, is 20. And is asking me to find, oh, sorry, I had the RT is 20. And it says find the segment RS. So that is the red piece. And this is where I can use my algebra skills to solve. So I have an equation. One piece plus the other piece equals the whole thing. So 2x plus 10 is 20 equals 20. So if I subtract 10, then 2x equals 10. And divide by 2, x equals 5. All right, so I solved for something, but I know I'm not finished yet, but I know x equals 5 is significant because that's x. So I like to circle those. I always box my answer when I'm finished, so I know I'm finished. But I know that's significant, so I circle whenever I solve for something before I'm finished and I'm saving it for later. I put a circle around it so I can find it on my paper easy. If you guys do that, you're welcome to do that. You don't have to. It's not required. Recommended. So now I've found x is 5, but I'm looking for RS, right? It says find RS. This is RS. So I'm going to take x as 5 and plug it in there. So it's 2 times 5, which is 10, is RS. Okay, so I have one more of these segment addition problems. B is between A and C. This time I don't have anything written. I have to do it all by myself. No steps. B is between A and C. There's my line. A to C. And B is in there somewhere. Or if I want, I could write segment AB. I need this up higher. Plus segment BC equals segment AC. Because once I draw my line, I can tell what that equation is going to look like. I don't know what pieces I have yet, but if you prefer the equation method over the number line method, then there you go. So now I'm going to look at the information I have. AB is 5x. All right, so from A to B, that's 5x. AB, it's 5x. So I'm going to go and fill this in too. And then what else do I have? BC is 7. From B to C, that's 7. So that's 7. And I also have AC. AC is 32. From A to C is 32. So one piece So one piece, this section, plus this section equals the whole thing. So 5x plus 7 equals 32. And I want to find AB. AB on the number line is this part, the 5x. So that means I do have to solve for x, even though that's not what my question is asking for. So I'm going to subtract 7 from the equation. And 5x equals, that gives me 25. Still solving for x, so I'm going to divide by 5. So x equals 5. So I found out that x is 5. I'm going to circle it and plug it into what I was looking for. I was looking for AB, the highlighted yellow part. It's right there. So that tells me 5 times 5, which is 25, is that piece of the segment that I was looking for. Segment AB is 25. All right, so segment addition postulate, one piece plus the other piece makes the whole thing. All right, so that's the first topic for today. The other topic is midpoint. Midpoint is very similar, but this time midpoint is not as vague as the segment addition postulate. And the between. That one said between, so we knew it was in there somewhere. When we have a midpoint, we know it's exactly halfway, right? Both pieces are going to be exactly the same. It's cut in half. So first we have to do the definition of congruent. Congruent means equal length or measure. And there's a symbol that is the equal sign with a little squiggle on top. That means congruent. I will use that a lot because I'll get tired of writing congruent eventually. Equal sign with a squiggle means congruent. All right, dash marks on segments also mean congruent. They mean the piece of the segment is congruent. So, dash marks, segments are congruent. So if these lines are on a line segment, those two pieces are equal to each other. So here, if I have this labeled A to B, and we have midpoint M, then segment AM is congruent to segment MB. No, BM. Minor difference. Don't worry about that too much. All right, so it means it's exactly the same distance from each endpoint. Let's do examples of those. If M is the midpoint of segment AB, all right, so I'm going to go ahead and do that. I have M is the midpoint of AB. And since it said midpoint, I'm going to go ahead and mark my segments congruent. If you see the word midpoint, mark the segments congruent. Because if you don't, and you just fill in all the other information, then you'll sit there and look at it and be like, okay, but how do I solve it? Because most of the time that's important because it tells you something. It tells you that they're equal. All right. So now I have if AB is 6, from A to B, the entire thing is 6, what is MA? And what is MB?
3.
Yeah, that's it, 3. It's because if the whole thing is 6, and we know the two pieces are equal to each other, well, if they're both 3, they are equal to each other, and they add up to be the whole thing. So 3 and 3. So that's your most basic examples I could do. Let's do another one. Step it up a little bit more in difficulty. Q is the midpoint of segment AY. All right, so I'm going to go ahead and sketch it. I have my segment AY and a midpoint, not just a point between, but Q is the midpoint. Because it says midpoint, I'm going to put the 2 dashes. So if AQ is 14, and YQ is 2x, what is the value of AY? Do I need to solve for x? There's an x in there. Do I need it? No. Because I already know what that piece equals, right? Because they're congruent, I know that it's the same as the other one, so I know it's 14 if this one's 14, because they're the same. So if they're both 14, then what's the whole thing? 28. Very good. So AY is 28. So don't just assume that you know what you're solving for and, oh, I see an x and you solve for x. No. That question didn't ask about x at all. All right, here's another one. U is the midpoint of TV. I like to sketch my line. My line is TV. U is in the middle. Because it's in the middle, I mark it as being equal on both sides. All right, what's next? TU is 4x. Right, T to U, that's 4x. VU is x plus 9. Okay? What is TU? All right. What can I do? How can I solve? Because I do have to solve for x on this one. What do I know about the two pieces? They're equal. So I can just say they're equal. So 4x equals x plus 9. Or I guess I could also say TU equals VU. So I have 4x equals x plus 9, and I'm going to use algebra to solve. So I need to subtract x to get my x's to one side. So 3x equals 9. If 3x equals 9, what is x? 3. Because you divide by 3 to get x by itself, and 9 divided by 3 is 3. I'm not finished, so I'm not going to box the x as 3. I'm going to circle it because it is important, and then look to see what I'm going to do with it. TU, here's TU, that's what I'm solving for. That says 4x. So if x is 3, then that's 4 times 3, and that is 12. So TU equals 12. And now I'm finished. All right, so I have one last example, because there are different ways the problems can be presented. So I just want to make sure I cover them so you don't have questions when you're doing your work. M is the midpoint of segment AB. All right. So here's segment AB. M is in the middle. So it's not just between, but the midpoint. So if AB is 4x plus 8, the entire thing is 4x plus 8. And MB is 3x. So from M to B is 3x. Find the length of MB. All right, so I only have the value for part of it and something for the whole thing. How can I solve this one? What do I know about AM? Yeah, AM is the same as MB. So if MB is 3x, then AM is also 3x because of that green dashed line that says that they're congruent because of the word midpoint in the problem. So I can set this up two different ways and they will give me the same, they'll end up being the same. You can do it however you feel more comfortable. If you would prefer addition and say 3x plus 3x equals 4x plus 8, you can do that. Or if you want to say I have 2 of the 3x pieces, say 2 times 3x, and that equals 4x plus 8. Both of those mean the same thing. If you either add it or multiply it, it's up to you, because they both end up being 3x plus 3x is 6x, 2 times 3x is 6x. So they both end up being 6x equals 4x plus 8. And then I solve from there. I subtract 4x to get the x's to one side. So I have 2x equals 8. And then divide by 2. So x equals 4. But I need to find the length of MB. So that is a 3x, right? So 3 times x, but x is 4. 3 times x, so it's 12. So 12 equals MB. Change that to red. Okay, so for today you have a worksheet where yesterday you had the online work.